This tutorial is all about salt, how it is extracted either from deposits in the ground or from the sea, and then how it is processed by electrolysis in order to make useful chemicals. In Britain we have underground deposits of salt, but in other parts of the world they have to extract salt from the sea. These salt deposits dotted around the world, shown in blue on this map, are the remains of dried up seas which have since been buried underneath other sediments. In these parts of the world, low-lying seas have been allowed to evaporate, have become more and more and more concentrated until they have completely dried out, and the salt deposits have been laid down in the ground and then covered over with other deposits. These salt deposits in Britain are in an area called Cheshire, deep underground. There are two ways of extracting the salt from underground. This way, using traditional mining, but using large-scale equipment, is done to get rock salt out. Rock salt is used for gritting roads in winter. The mines can be very deep and don't need any pit props because the salt itself is incredibly strong. The other way of extracting salt from underground doesn't involve people having to go underground, which is therefore much safer. This is called solution mining. Water is pumped down underground and it reaches the salt deposits, it dissolves the salt from those deposits and it becomes salt solution or brine. That's then pumped back up to the surface. It's filtered to get rid of any bits of sand or grit, and then sometimes it's treated in order to remove any of the other salts like the calcium or the magnesium salts, leaving just sodium chloride solution. This sodium chloride solution can then be sold to industry, or, in order to make salt for food, the water is removed by a mixture of heating and a vacuum. One of the issues of extracting salt from underground is that sometimes the land subsides. This subsidence, in a rural setting such as this, doesn't cause a particular problem. However, in towns and cities, the subsidence can cause damage to buildings. Indeed, the subsidence at this salt mine in Kansas was so extreme that they had to move the railway track to skirt around it because there was no way that they could fill that hole up. Salt can also be made directly from the sea by allowing the seawater to flood lagoons. The lagoons are then shut off from the sea and allowed to evaporate under the sun's heat, and eventually all the water evaporates and salt is left behind. This is then harvested and sea salt is then sold instead of ground salt. The specification says that you should know about the electrolysis of concentrated sodium chloride solution or concentrated brine, and that this gives three industrial chemicals: chlorine, hydrogen and sodium hydroxide solution. This is done using a method called electrolysis. A concentrated solution of brine or sodium chloride is the electrolyte. Electricity is passed through the brine, shown here using a lab equipment, by using two electrodes. The positive electrode is called the anode, the negative one is called the cathode. At the positive electrode, negative ions, chloride ions, are made into chlorine and chlorine gas is collected. Chlorine can be detected using litmus paper. Damp litmus paper is bleached by chlorine. At the negative electrode, positive hydrogen ions collect and are discharged as hydrogen gas. Hydrogen can be tested using a lighted splint. Hydrogen will pop with a lighted splint. As the solution becomes depleted in hydrogen ions and in chloride ions, as the hydrogen and chloride are made, the solution becomes more concentrated in sodium ions and hydroxide ions. This means that the resulting solution is concentrated in sodium hydroxide. Sodium hydroxide can be tested using red litmus. It turns blue because sodium hydroxide is a strong alkali. Here's an exam question. Brine is a solution of sodium chloride. Solution mining is used to get brine out of the ground. Look at this diagram of solution mining. Write about one major environmental problem caused by solution mining. Okay, this is subsidence. Hydrogen and chlorine can be obtained by the electrolysis of brine. Describe a chemical test for hydrogen gas. Well, the test would be to add a lighted splint and the hydrogen explodes with a pop. Describe a chemical test for chlorine gas. The test would be to add damp litmus paper, and here the result is that the litmus bleaches or turns white. And here are the acceptable answers from the mark scheme. This question is about chemicals made from sodium chloride. A solution of concentrated sodium chloride is electrolyzed. Look at the diagram, it shows the apparatus used. This is the industrial apparatus, which is a better way of doing it. It's called the membrane cell because it's a continuous process. The sodium chloride is continuously put in at the left-hand side. Solution X is continually coming out at the right-hand side, and chlorine and hydrogen are being made at the two electrodes. Hydrogen gas and chlorine gas are made. Write down a chemical test for hydrogen. Well, the test is to add a lighted splint and the result is it goes pop. And a chemical test for chlorine is to add damp litmus paper. Doesn't really matter which colour you use. And the result is it bleaches it. Solution X is also made in the electrolysis cell. What's the name of that solution? Well, the remaining solution is sodium hydroxide. And here are the answers, the acceptable answers for those questions. Another question, look at the apparatus she uses. Bubbles of gas are made at both electrodes. Chlorine is one of the gases made. Write down the name of the other gas made during electrolysis. That would be hydrogen. And chlorine is a very important chemical. It has many uses. Write down one use of chlorine. Well, one use of chlorine is for water treatment. It kills bacteria in drinking water. Here they refer to it as sterilizing the water. It's also used to make solvents, to make bleach, to make plastics, and so on.